The idea behind this question is even more important than the question itself. Write the equation of reaction of hydrogen with copper 2 chloride. Now look at the idea behind this. And the idea, like I said, is more important. Because if you have the idea, there is no need, absolutely no need to cram chemistry. Reaction between hydrogen and copper 2 chloride. The first thing you do is to write the formula for copper 2 chloride. Then plus hydrogen. Now you ask yourself, what is this hydrogen going here to do? First of all, we are going to check if each of these elements is a cation or an anion. Copper is a metal, so it's a known cation with oxidation state 2+. Chlorine is a non-metal and it is bonded to a metal, so compulsorily it is an anion with -1 oxidation state. Hydrogen is a non-metal, right? But when you compare hydrogen with chlorine, you will see that chlorine is more electronegative than hydrogen. In simple terms, chlorine is more non-metallic than hydrogen. And evidently, hydrogen can form a cation, so it is +1. Now look at this. What is a cation going to do in a compound that already has a cation? It is going there to displace that cation, to show that it is a beta cation. Because once hydrogen reaches here, it is going there to destroy the marriage that is already existing between copper 2 and chloride. And if it successfully proves that it is a beta cation than copper, it means that it will displace copper from the compound. But we are not going to determine this by head knowledge. We have to consider a rule, the rule of electrochemical series of metals, including hydrogen, which has the ability to form a cation. And I will summarize this rule by an acronym which says PSC Mazit could make silver and gold. P stands for potassium, S stands for sodium, C stands for calcium, M magnesium, A aluminium, Z zinc, I iron, T hydrogen for hydrogen, could copper, make mercury, silver, and gold. It is like a ranking system. As you go from here to here, the reactivity decreases, which means that any metal that comes before another one has the ability to displace it. Potassium can displace sodium from a compound. Potassium can displace calcium from a compound. But note, after potassium you see sodium. The ability of potassium to displace calcium is more than the ability of the same potassium to displace sodium. Why? Potassium and sodium are direct neighbors. The ability of potassium to displace copper is even higher than the ability of potassium to displace hydrogen. So in this reaction, the competition is between hydrogen and copper. You can see that after hydrogen, you see copper, which means hydrogen can displace copper. But this is under a forcing condition because they are direct neighbors. The ability of hydrogen to displace copper is so small. And therefore, that brings us to reaction condition. You must add it with heat. It is just like a pregnant woman whose time of delivery has not reached, and you tell the woman to deliver. You have to inject the woman with necessary hormones like oxytocin, which will now force the baby to come out against the natural process. So, for hydrogen to displace copper, naturally it is possible, but it is under a forcing condition. That forcing condition is involvement of heat. You must heat the system. So you write heat on the arrow, and then hydrogen displaces copper, and we have hydrogen chloride instead of copper 2 chloride. Plus what? Copper will now come out as element, atomic copper. To balance the equation, both chlorine and hydrogen are 2 atoms each at the left. And for God so loved the world that 2 of them have now married to form one compound. So you write 2 at their back. Copper is 1 at the left and 1 at the right. And this is the equation of reaction between copper 2 chloride and hydrogen gas. Please let me remind you, we are just 22. close to our first 1,000 subscribers. If you are new here, please click on subscribe and on the notification bell. Thank you and welcome to the family. Bye.